Hello, this is an introduction to RefactorGraph Visual Studio extension. It is a tool for node-based code refactoring. It is currently adopted for C#, but it is possible to make it work with other languages in the future. Please note that this is a work in progress, so many features are still missing, and it's also not guaranteed to be stable. So if you decide to use this extension, make sure to save your work. If you experience any issues, please report them on the GitHub issues page. The way RefactorGraph works is it splits the document into multiple partitions. These partitions can be modified. So for example, we can change their contents, we can remove them, we can swap them, or we can even insert new ones. Or they can be split into further smaller partitions. Once all the modifications are done, we can put them back together into the document. So looking at this graph, we start with the document node. We apply some partitioning operation, typically some regex operation, to extract P1 and P3. Notice how the document is still intact, as we can traverse the partitions using previous and next functions. The partitions themselves are connected with the doubly linked list. Further, we apply another partitioning operation, splitting them further into P1_1, P1_3, P3_1. Then we modify them. So for example, we changed contents inside of these partitions. Then finally, all we need to do is traverse from the root node to create the final document. To use the RefactorGraph extension in Visual Studio, we need to install it first. Go to Extensions, Manage Extensions. In the online, type RefactorGraph. I already have it installed, but you will have an install button. Once the installation is complete, you will need to restart Visual Studio. Once restarted, you can go to Tools, Show Refactor Graphs. This will bring up the Refactor Graphs menu. From here, you can manage all the graphs that you have. In the project, you can also create new ones, or delete them, or run them. Let's create our first refactor graph. In the Refactor Graphs menu, click on the plus icon. A new refactor graph with the default name has been created. Let's rename it to Hello World. Also, if you notice, the canvas has been displayed on the bottom. When you first install the extension, it will probably show up as a small floating window somewhere. So you can expand it and dock it however you like. I prefer to keep it on the bottom because it makes it easy to see both the graph and the code. Every refactor graph starts with a start node. The start node captures the active document or active selection. So if we want to work on the entire document, make sure nothing is selected. If you want to work on the active selection, just select some code here. The start node has two ports. It has an out port, which is our execution port, and execution goes from left to right. And it has a result port, which is a property port, and it returns the partition of the captured document. For this tutorial, we'll do something really simple. We will rename the value of parameter 2 from test to hello world. There are two ways to create new nodes on the graph canvas. You can either right-click to bring up the context menu, or you can click on the wrench icon to bring up the toolbar. I prefer the toolbar method because it makes it easier to see. The toolbar contains all the nodes that we can work with. So in our case of trying to rename test to hello world, we are going to have to partition the document first by the word test. For this, we have a specific node called partition by all regex matches. What this node does is it finds every occurrence of this pattern and it combines them into a collection of partitions. So for this example, we will change the pattern to test. We will connect the output port from start to input port of the partition by regex matches, and we connect result to source here. As you notice, partition by all regex matches returns the partition collection, which means we will need to modify every occurrence of the every element within this collection. And for this, we can use the for each node. Just like in code, for each node iterates through every element in the collection, and it executes the loop flow port, and it returns the element. Once the iteration has been completed, it will execute the completed port. So we pass partition over here, and then for each element we want to set the partition data. And for that we have a node called set partition data. So we will connect loop to input here, and the element to the input of the partition here. Now, what do we want to set it to? Well, we want to set it to hello world. And that's it. That's our simple graph. To run this, simply click on the green triangle. And if you look at the document, it has been modified. But this is a very basic scenario, which can simply be replaced by using Ctrl F, typing test here, and replacing that with hello world. But what if we have a comment that uses the word test as well? If we run a refactor graph right now, it will rename both the test here and the test here, which might not be what we are trying to achieve. Let's say we only want to rename the value of parameter 2. To do this, let's create a new graph. Click on the plus icon. Let's rename it to something like name param2. And for this we have a specific node called partition by variable assignment. What this node does is it searches the entire document for any variable declarations or variable assignments and partitions the document by these. So again, we pass the result into the source, and here we have an interesting option called variable name filter regex, which lets us filter out only specific variables that we want to modify. In this case, we only want to work with param2. As you notice, partition by variable assignment node also has a loop and the completed nodes. The loop will iterate through each occurrence of variable assignment. And for each occurrence, it will return all these following parameters. So in our case, we want to take the variable value. Let's say it's still test. And we want to change that variable value to hello world. So again, we will use a set partition data, pass that into the loop, and then we pass variable value as a partition and change this to hello world. Again, run this graph, and now you see that the parameter 2 value has been changed, but we forgot, of course, the quotes. So since we're modifying the entire variable value, we want to also include the quotes. And the comment parameter has been unmodified. Another interesting thing we can do with refactor graphs is we can swap parameter order. So let's say we want to swap the order of parameter 1 and parameter 2 in a function called foo. Let's create a new graph. Let's call it swap parameters. And for that we need to use the node called partition by function call. Again, connected as before. As you notice, it also has a completed and loop output execution ports, and it basically will partition the document by every function call, and it will execute everything for every function call under the loop. So we also have a function name filter regex, so in this case it will be foo. You can be also more specific with your regex. For example, you want to put a word boundary here to make sure there is no like a foo 1, 2, 3 or something that you don't want to modify. And it returns function parameters, which is a collection, a partition collection. And let's say we want to swap these two, so we will have to use a node called getElement. So we'll pass this as a collection. We'll take the first index, the zeroth index, that will be the first element in the collection. And we will also need to take the second parameter, which is the first index. Alternatively, we can also use get first element and get last element to avoid using indexes. Now, once we got both of these partitions, we want to swap them. And for that, we have a swap partitions node. So for partition A, we pass this element, and for partition B, we pass this element. And again, we connect it here. Now, once we run this, okay, it didn't run. If you notice, the red sign is because we forgot to pass the partition collection, which is the function parameters. Now we run this again. Now we can see the parameter 2 now precedes parameter 1. But if you notice, we also have a function definition here, which has not modified this parameter order. Let's try to do that as well. Let's create another graph. Let's call it swap params 2. And then in this graph, we are going to change the parameter order in the function definition. Okay, so for this one, we are going to use partition by function. And this node specifically partitions the document by function definitions, not by function calls. Otherwise, it works very much the same way as the partition by function or partition by variables. So in function name filter regex, we are going to pass foo, and this time we are going to use get first element and get last element to get our parameters. Again, we can connect the loop port because we are going to modify every parameter occurrence, every occurrence of the partition. And we're going to pass function parameters into the collection port for both of these collections. And finally, we are going to use the swap partitions node. Let's change this back. Okay, so now once I run this, it will indeed change the parameter 2 and parameter 1 order. But if you notice, the function call order has not been changed. So how do we actually modify both the call and the definition? There are several ways of doing this, but for this one, we're going to use something called reference node. This allows us to use the actual graphs as nodes in the canvas. So let's create a new tree, a new graph. And we are going to just drag and drop the graphs in here. So we have swap params, and we are going to drag and drop swap params 2. and we are going to pass. Actually, for this situation, we probably best to use another node called bus node. And the bus node is basically provides us with an ordered execution. We can add more outputs, or we can delete them, and they're executed from top to bottom. So first we'll swap params in the function call, and then we'll swap params in the function definition. And both of these require the result. Now if we run this, okay, if you notice, this was already swapped, so let's make sure that this order is correct. Now if we run this, and indeed both of these functions have been, both of the function call and function definition parameter order has been modified.